Okay, once again back to Department of Zoology, TY B.Sc Zoology Semester 1, Paper 4, Environmental Biology and Toxicology. Code is ZY334. And I am presenting this topic, Dr. Chowre CS. From your university course syllabus, we are discussing topic number 3.4.3, ozone layer depletion. Already we have discussed various types of air pollution. Among that, now we'll give more emphasis on ozone layer depletion. What is air? If we ask to ourselves, air contain around 78% nitrogen, 21% oxygen, 0.03% carbon dioxide, and less than 1% inner gases are there, and rest are the water vapors. So majority portion is of a nitrogen and very less amount of CO2 is there. Apart from this chemical nature, what air is, it's a tasteless, odorless and invisible mixture of gases that surrounds our earth. Now, what is air pollution? We have discussed it earlier already, but for revision purpose, it is a gases or particulate substance released into the atmosphere in sufficient quantity or concentration to cause injury to plants, animal and humans or human belongings. That is what is a pollution. And if it is a air, then the particulate and gases released in the surrounding atmosphere, that is a air pollution. Typically that emitted into the atmosphere and transported from the source to the affected organisms. Okay, that gases or particulate substance which are emitted in an environment atmosphere, they get transported through air into different sources where that organism get affected. That is what is the air pollution. Air is said to be a polluted when it is no longer tasteless, odorless or colorless, or it varying its chemical composition. Then we say that air is a polluted. We are more focused to the ozone layer depletions, or if that ozone layer is get concentration of ozone layer in that atmosphere, if get change, what will happen to the earth and organisms over the earth, that we will see here. So ozone, in chemical language we write that ozone as O3, a three molecule of a oxygen, a gas which is composed of three atoms of oxygen. In color way, if you see, that gas is a bluish gas and that is harmful to breathe. We cannot breathe O3. It is not O2 oxygen, though it is a molecular nature is oxygen, but there are three atoms of oxygens, so it is very harmful for us for the breathing purpose. And that ozone is not present in our near vicinity. So nearly 90% of earth ozone is in the stratosphere and is referred to as the ozone layer. Okay. It is far away from our breathing air in above in the sky, so it is in a stratosphere, so we don't have to breathe that O3, that ozone. Now why it is, what is the benefit of having that ozone layer that is in a stratosphere? That they absorb ultraviolet radiations that called as a UV, that ozone absorbs a band of ultraviolet radiation that is called ultraviolet bands. Okay, so ozone here, if it is near to us, then it is a very bad, and if it is up in a sky, then it is very good for us. There are two types of ozones. One is located in a stratospheric layer that is called the ozone layer. It is a good zone for ozone, and it is above ground around 15 to 50 kilometer away from our earth crust. And another uh, another ozone present in our environment is a tropospheric ozone. That is a very bad ozone. it, it is accumulated between 0 to 15 kilometer of our uh, earth crust, our first layer from the soil earth to the toward the sky. In a tropospheric layer, if it is there is a ozone, then it is very bad because we cannot breathe, it is toxic to us. But if it is in a stratospheric layer, then it protects entry of that ultraviolet rays. All ozone is within the first 50 kilometer of Earth's atmosphere. So that is the main thing. Ozone should be between 50 kilometers of Earth's atmosphere. Now these two layers of ozone is shown in this photograph here, a good one and a bad one. So a good one which forms a protective layer over the this troposphere in the form of that stratosphere. It forms a protective layer. That way they arrest the entry of ultraviolet rays. So too little there, it is very less there. Many popular consumers products like air conditioners and refrigerators involve CFC gas release or halogens during either manufacture of these air conditioners or fridge. Over time, these chemicals damage the Earth's protective ozone layer. Now, how that damage CFC, how that CFC react with the ozone and what happened to the ozone layer, that we'll see in detail later on. But the basic thing is these CFC gases are damaging the ozone layer. Then another one which is bad for us is because of some industrial activities, we are producing O3. So too much here, that is car, truck, power plants and factories all emitting air pollutants that forms ground level ozone, a primary component of a smog. What we see all everywhere, there is a smog kind of a thing. Generally at the evening time, everything gets smoggy, or after around after morning, or after around 8 to 9 a.m. Slowly, if you see around horizon, you will find everything gets smoggy or blurred. It is not very clear as compared to the clarity of the picture. Clarity of our vision is more during the morning 6 to 8. You will find everything looks very clear. But after 8 to 9 a.m., everything start becoming hazy. That smog is a outcome of these industrial activities, and that is again a O3 produced. That is a bad O3 at the wrong place. It is a at the wrong place. Okay, so here in this diagram again you see how that CFC, what we said just now, that CFC is damaging the ozone layer. How it is? See, this CFC get released through these air conditioners or refrigerators things, and it rise into the ozone layer, and it that UV release chlorine from this CFC. When it come contact with the UV light, sunlight, that CFC release that chlorine, and then chlorine get attached with the one of oxygen present in a O3, and split that O3 into one molecule of oxygen and another oxygen, one molecule of oxygen, simple nascent oxygens O, and another O2, and that way ozone gets split into the one single O and another O2. that that way ozone vanishes from the ozone layer. Now it become oxygen, and that oxygen combined with the chlorine and get settled down here. Because of formation of O2 from the O3, that ozone vanishes and it allows the entry of more UV to the earth surface, and that excess UV when come in contact with our skin, there happens many medical issues like skin cancer. So here again in this diagram we can see the smog layer around the city. The smogging is a result of a second type of ozone developed after because of that industrial activity, and this protective ozone layer above the stratosphere, that is a good kind of ozone. Now, ozone depleting substances. What are the ozone depleting substances? What are the chemicals which are causing conversion of O3 to O2? So this one of CFC gases are there, HCFC gases are there, halogens are there, methyl bromide, carbon tetrachloride, and methyl chloroform. These are the chemicals which react with the O3 and split into the oxygen. Now, various sources that harm the protective ozone layer. Other products, including halogens, are 12%. Majority product is a solvent cleaning product, that is 36.1%. These aerosols, what that deodorant spray or color spray or any kind of automatic spray we use, that is packed with the aerosols, and that aerosols contain these CFC gases. So when you release that gas, it along with the your scent chemicals, it goes sprayed into the area, and that CFC gas gets released in a nature and it goes up and react with the O3. Foam product, many times while shaving you have used some of you have used that foam shaving cream. That foam is formed because of mixture of aerosols in that, and that way you can release that uh, chemical or ozone depleting substances into the environment. Then refrigerations and air conditioning gases are CFC gases, that gradually goes on releasing into the nature. And so we say that after few years we say that the air conditions is not working because there is a no gas in it. We have to refill that gas, and where that gas goes, previous gas goes, that goes into the ozone depleting layer. So that gas goes and feed on ozone O3 and break it into the O2, and that way makes hole into the ozone layer in stratosphere. Then sterilization product also are responsible for the releasing that one of oxygen from ozone layer. Effects of ozone layer depletion on us. First primary is a skin cancer, melanoma or non-melanoma cancer. Okay, that is not a direct impact of ozone on our skin, but that is an indirect impact as ozone layer depleted, ultraviolet rays directly reach to us and that cause cancer. Then premature aging of a skin and other skin problem. If you continuously remain in a direct sunlight during the afternoon time, that sunlight contain lot of ultraviolet rays and that quickly burn your skin, or they start aging of your skin. Then cataract and other eye damages are prevalent if there is a more ultraviolet rays. So these are not a direct impact of ozone, these are the indirect impact of ozone layer depletions on us. Immune system suppression is one of a reason, because in a high UV containing sunlight there is an because of that we cannot produce that vitamin D, and instead of producing or helpful aspect of sunlight, it cause damages more, and that way it affect our immune system, they suppress our immune system. Then health issue arises because of this ozone layer depletions. It is not because of ozone layer ozone gas, but it is because of depletion of ozone layer. Now here these health issues are more related with the presence of ozone in our surrounding. Here respiratory problems are much more because of inhalation of O3 ozone layer, coughing, congestion, chest pain, throat irritations, worsens respiratory diseases such as asthma, bronchitis, and emphysema. These are all because of inhalation of toxic O3. Environmental vegetation injury is one of the reason of this O3. Direct impact of ozone layer, direct impact of this ozone gas on the vegetation. Ozone pollution can cause a variety of injury on vegetations, including agriculture crop here and commercial forestry species. They stipple that ozone cause uh, chlorotic mottles and reduces crop yield and premature defoliations. These are the direct impact of ozone on vegetations that also cause injury such as that can turn affect the economy of agriculture and commercial forestry sectors because of accumulation of ozone in a forestry or vegetation or agriculture belt. It directly impact on economy, reduce crop yield, that is a direct impact on economy, agriculture economy. Yeah. Now another damage of depletion of this ozone layer in a stratosphere is a development of this Antarctic Antarctic zone hole. Now the significance of this hole in a ozone layer at Antarctic region is very different because if that the if the ozone layer forms hole at this region, the more and more UV light will penetrate that sky and reach to the glaciers, and that will fasten the process of melting ice, and that indirectly lead into the rise in a seawater level. Also, that will disrupt the water current, natural water current present in a sea, and that will affect on our season get disrupted, and all this lead to the origin to the ozone hole, lack of ozone in a ozone layer. So the ozone hole is defined as the area having less than 220 Dawson's unit of ozone in an overhead column, that is between the ground and the space. That is called as a ozone hole. What can we do? Now, up till now, I think we understood the reason and origin of this problem and the impact of this pollutant on ourselves directly, indirectly, and on our vegetations surrounding agriculture. So what we can do here for this, to make sure that the technicians working on your car air conditions, home air conditions, or refrigerators are certified by proper environmental monitoring authorities to recover that refrigerant gases. When they change the gas, they should recollect the exhausted or unwanted CFC gas before refilling it. Have your car and home air conditions units and refrigerators check for leakage. When possible, repair leak air condition before refilling them. Otherwise, you will go on refilling the air conditions and the gases will go on releasing into the environment. Then contact local authorities to properly dispose of refrigerations or air conditioning equipments. Many times we directly throw that into the garbage and that gets leak, broke down, and the gases get released, that CFC gases are released into the environment. Protect yourself against sunburn. We should avoid entry in a high sunlight during daytime. Minimize sun exposure during midday hours between the 10 a.m. to 4 p.m. Wear sunglasses to reduce the impact on your cataract. A hat with a wide brim and a protective clothing with tight weaves use a broad spectrum sunscreen with a sun protection factors of least 15 to 30 is better. Sunscreen lotion you can apply on a skin to prevent yourself from getting the skin cancer. Now, one point we'll emphasize and discuss how that ground level ozone formation take place. Okay, up till now, whatever we have seen the sources and if that ozone layer depleted in a stratosphere, what will happen? But in detail, little bit we'll go now to see how these ground layer ozone formation take place. Where does ozone come from? Okay, it is naturally present in a stratosphere, but additionally we are producing ozone. And what is the source of that? Is here. This precursor of ozone is a nitrogen oxide gases and VOCs. Now here many these vehicle originated gases are there which are entering into the atmosphere. What are precursors? Primary pollutants gases that form the secondary pollutants. It is a chain. At this exhaust of car, it produce a chain reactions which finally lead to the production of O3. It's a primary pollutant it creates, then from the primary it produces secondary pollutants and then it goes and forms the O3. How does ozone form? Now these are the different reason for the production of that sources of nitrous oxide gases and these VOC gases here. Okay, so around 56% come from the motor vehicles, and here it is industrial or commercial processes releases this VOC in atmosphere. Then from the utilities and from industrial, commercial, residential fuel combustions, we release around 70% here. Then all other sources contain that 5%. Okay, so overall VOC and nitrogen oxides release reason is major reason is a motor vehicle. If you see in both this diagram, the major reason is a motor vehicle and second reason is a industrial commercial processes releasing this secondary pollutant, primary and secondary pollutant which produce this O3 at the very near to us below 15 kilometers height and atmosphere. So these nitrous oxides and VOCs come together in presence of sunlight. They forms the O3. Okay. Now ground level ozone formation take place because the secondary pollutants that is VOCs and nitrous oxide these come and they forms the ozone in presence of sunlight. That ozone plus these nitrogen oxides and HCs gases they form the hazy smoke around our city. Okay, see how this primary and secondary pollutant lead to this development of this ozone and carbon monoxide and this pan and the haze. Okay, so this car vehicle releasing this exhaust, that exhaust in presence of sunlight, it is developing into the carbon monoxides and nitrogen oxides. Then this oxygen then combine with one more Nissan oxygen and form the this O3. The smog sources of smogs are all these the same vehicles, industries, and that diesel particles, everything that forms the fine particle presence of ozone, and that together they develops a smog. Sources of volatile organic carbons. The what are the sources volatile organic carbons? They are mainly the fossil fuels and industrial exhausts producing these volatile organic carbons. And sources of nitrogen oxides is again this car vehicle exhaust that is a fossil fuels, then electricity generating plants and industrial combustions. What we can do, you keep your automobile well tuned and maintained so that it should emit very less amount of this nitrogen and these VOCs. Then carpool, reduce the use of car vehicle, these fossil vehicles running on the um, fossil fuels. You try to reduce the use of vehicles running on the fossil fuels. Try to use bicycles more. reduce driving during hot summer days. Try avoid that use of cars. Be careful not to spill gasoline when filling up your car or gasoline powered lawn and garden equipment during the summer. Fill your gas tank during the cooler evening hours. Now, when you open the vent of this gasoline, that petrol gas or diesel gas quickly evaporate, and if it is a hot summer days, then that evaporating fossil fuels it react and that quickly get converted into O3. Make sure your car tires are properly inflated and your wheels are aligned so that there is a less frictions and less emission of gases. Participates in your local utility energy conservation programs. Seal containers of household cleaners, that workshop chemicals and solvents and garden chemicals. Many times we use many solvents and we keep open that lid of that container of a solvent. That evaporating solvents is a major source of a production of these VOCs, and that lead to the development of a O3 ozones in a layer. Dispose of them properly.